In the final video within this module, I'm going to be going through an advanced application of entering inputs, which I like to think of and call blending. And it relates to how we can actually recognize that we have bias in our own assumptions. Blending helps us account for that bias that we have when we're entering ranges. As we've discussed, we aren't going to do a really good job of understanding the ranges that our opponents might have. I've mentioned this before, I'll say it again. I don't know a lot of players who has a perfect sense of his or her own range. If you don't necessarily know your own range, you're not going to have a really good shot at perfectly ranging your opponents. And that's where blending comes into play. It's unavoidable for us to inject bias into those input assumptions. And as a result, there's going to be an additional margin of error that's associated with that output. These biases are most present in this selection of our ranges because our other inputs are just not as heavily subjected to our judgments. When we are entering bet sizes, yeah, we do have some judgments that we're making, but a lot of times those are grounded in the parameters of the actual gameplay. Whereas ranges, we have to make a lot of decisions. We ultimately have to choose 1,326 different combinations, and at what frequency each one of those combinations is present in a particular range. There's just an infinite number of ways in which we can actually construct that overall range, and we're just not going to be perfectly accurate. Now, solvers are going to strictly implement the ranges that we enter, and only the combinations that we enter are going to be included in a solver's output. And this is important. How many times have you been playing in a live game and someone shows up in a situation where they have a hand that you just have no idea that they would have had in the first place? If you didn't put that in your solver, then the solver wouldn't account for that. Even at a micro level, the solver wouldn't necessarily account for that in calculations. But luckily, we actually have an opportunity to enter weighted partial combinations to include more overall combinations in a calculation while not necessarily changing the macro level frequency that much. And that's where what I'm going to call blending. Blending helps us hedge for our bias by accounting for that uncertainty and gradually implementing the edges of both our range and our opponent's range into our input process. So let me just walk through how blending works. When we blend, we want to start with a set of macro level frequencies. So we want to start with a set of frequencies that we want to keep at a high level and not change from. And when we start with that macro level frequencies, we maintain those in blending, but create some gradual transitions at the edges of those ranges. By creating gradients at the edges of ranges, it helps us account for uncertainty, but it also models reality more clearly. So rarely in actual gameplay will an opponent always play one hand and then never play another hand one pip lower. It tends to be more of a gradient. They might play one hand 75% of the time, and then one pip lower, they might play it 25% of the time. And that's where blending comes into account, where we can keep the overall makeup from a frequency standpoint of our range, but kind of be a little bit more smooth around the edges. So we start moving away from vocabulary of always or never, and we introduce additional descriptors such as usually or sometimes or rarely. But by blending ranges, especially our opponents, where we may have less clarity, we can account for additional combinations in our model and increase the credibility of our outputs while maintaining our macro level frequencies. So let me just show you here an example of blending in action. So let's say we have this under the gun open, and using pure frequencies, this under the gun open maybe opens 19.3% of hands. And notice here in this range, I don't have any partial frequencies. So we are in this range, the under the gun player is opening an ace 10 off 100% of the time, king jack off 100% of the time, but never opening king 10 off, never opening queen jack off. They're opening fives 100% of the time, but never opening fours, and so on and so forth. But this ultimately works out to 19.3% of hands and 256 combinations. And this might be like an under the gun range for a online 6-max game. If I were blending here, I can introduce some uncertainty here. So this blended opening range still maintains this high level frequency of 19.3% of hands. It also maintains this combination weighting. So instead of 256 combos, it's now 256.5. So reasonably the same. But you'll also see now that we have coverage over more hands. And that's going to help us account for some uncertainty that we might have in this initial range. So now we can account for the possibility that our opponent might also have some lower end pocket pairs. They might have some additional offsuit broadways. There might be some additional hands here on the edges that our opponents might have. Whereas they also, some of the hands that I had at 100%, so King 7, Queen 8, Jack 8, 10 8, these hands we've discounted a little bit. Going back to, again, instead of saying they always have something or they never have something, now we can kind of start using a little bit softer language to say they might usually have something. So 75% could account for usually, or King 5 suited here, this 25% could account for them. They rarely have this hand, but they sometimes might have it, right? So we're softening our language somewhat, but by doing so, we can account for more overall combinations at a unique combination level, but keep the overarching combination frequency constant. Some general considerations that we want to take into account here when blending. One is, how much range clarity do we have? We don't need to blend here if we are working on our own set of ranges and we know exactly what our ranges look like. Whereas if we have a little bit less clarity, we may want to lean on blending a little bit more. Again, online versus live, you're going to have more clarity over ranges in the online world versus the live world. So I may tend to blend a little bit more in that live arena. Test objectives and goals. So what are we actually trying to test for may determine whether or not we want to blend as we're adding ranges. And then history and player profiles and things like that. Now, blending is an art. It's not a science. There is not an exact range that we're going to work with here. And as you'll see as we jump into the solver examples in a minute, a lot of times we start with this baseline and we're kind of just working around the edges, adding hands, removing hands, increasing weights, decreasing weights, while trying to maintain an overarching high-level frequency. It's meant to give us coverage over more scenarios to help us create some flexibility in our model, but it's not meant to be something that's perfect. So feel free to test a lot of different iterations, but don't worry about trying to get everything exactly perfect. By adding some level of blending into your models, you're going to ultimately increase the accuracy of the model anyways and account for more things. So let's jump over into a solver and we can actually see how we might blend as we're entering inputs of ranges.